Hello everyone, welcome back to my YouTube channel. It's been a while. In this video I'm going to show you a mathematical model to solve cubic equations. Now this model is in regard to how the famous mathematician Tartaglia solved the reduced cubic equation. Now a normal cubic equation would be of the form ax cubed plus bx squared plus cx plus d equals 0, where a is always non-zero. But in a reduced cubic, we put this bx squared term to 0 and we get an equation ax cubed plus cx plus d equals 0. And if we divide everything by a, we get an equation of the form x cubed plus c by a, which say p, x, plus d by a, which we put as q. So this is the standard form of a reduced cubic equation. Now we are going to solve a reduced cubic in the way Tartaglia did it. And we are going to consider the equation x cubed plus 36x plus equals 208. Now we consider the geometrical meaning of x cubed. It is just the volume of this cube with sides x. And when you add a volume of 36x, you get a shape with a volume of 208. Now, Tartaglia, what he does is he extends three sides of this cube by some length y. So, say this is y, one side, another side, and a third side. Now, when we do this, you can see that there are actually extra volumes that are formed. And when you fill in this volume, you can actually see we get 7 different shapes. 4, 7. So the additional volume is just 3 cuboids with dimensions x by y. Y is just the length to be extended by, and here these are 3 cuboids with dimensions x by y. And we also have a cube with volume y, which means that all of its sides, volume is y cubed, which means all the sides are just y. Now, what Tartaglia does is he arranges the cuboids like this. X by y, 3 of them are kept like this, and y by y, the x by y, they're kept like this. So we get a new cuboid. Here, its length is x plus y, its breadth is just y plus y plus y, 3y, and its height is x. So we have x plus y, which we will actually call z for convenience. X plus y, which is z, breadth is 3y, and height is x. So the volume of this new shape is just 3 x y z. Now what Tartaglia does is he realizes here, this is also, we can also write this as 3yzx. So he realizes that this perfectly represents this term of the equation, 36x. So what he does is just equates 3yz equals 36. From this we can solve and get yz equals 12, or z equals 12 by y. And this is important because we'll need it later. Now, since this is now 36x, when we add it to the x cubed, we should get the left hand side of the equation, x cubed, and all of this together is 36x. But we see when we look at the LHS, left hand side, there is a gap. This is perfectly filled by our cube of volume y cube. So when we complete the cube, we see that we get a new cube with side lengths x plus y. which we have called Z. So this is the LHS plus this additional volume. But since when we do something to the LHS, we also have to do something to the RHS. So since we added a volume of y cubed, we can add c plus 36x plus y cubed equals 208 plus y cubed. Now this is the cube and its volume is this. Since its side lengths are just x plus y or z, we can write this as the volume of that cube, which is z cube. This is equal to 208 plus y cube. And we actually know what z is in terms of y. It's just 12 by y. So when we substitute, we get 12 by y, the whole cube is equal to 208 plus y cubed. Now we expand this, we get 1728 by y cubed equals 208 plus y cubed. And when we multiply by y cubed every term, we get 1728 equals 208 y cubed plus y cubed times y cubed, which is y raised to 6. And we can actually write y raised to 6 as y cubed the whole square. So what would have been an equation in degree 6, which is kind of petrifying and intimidating, we can write it as a quadratic equation by simply putting t equals y cubed. So when we do that, we get a completely new equation. 208, t squared, this term, plus 208 plus 208 t, this term, minus 1728 equals 0 by rearranging. So here we've changed the degree of the equation completely. We started with a cubic, we got degree 6, now we've ended with a quadratic equation, degree 2. And this, we use a simpler version of what we've done here, completing the cube, and we complete the square. Here, we also take the geometrical meaning. T squared is the area of this square with side lengths t. And 208t is actually the area of a triangle. Not triangle, rectangle. So it's originally 208t, but we split it like this to get two rectangles with length 104, breadth t. So both of these are identical like that. So we split the original rectangle 208t into two smaller rectangles 104 by t each. And the sum of these is equal to 1728. An area of 1728. So we can actually add this, we can keep this like this. And we see that there is in fact, we can complete the square by adding an area of 104 squared. We get this by here, which is, this is 104 and this is 104. And on the RHS, we have an area of 1728, and we had 104 squared, which is 10,816. And when we add this, we get this area, an area of so the area of this is 12,554 square units, and the area of the LHS is, we see that this side is t plus 104 and this side is t plus 104, so this is in fact a square, and the area would be t plus 104 the whole square, because this is the side, is equal to 12,544. And as it turns out, this is a perfect square. And we get t plus 104 is equal to the square root of this, which is just this side, and it turns out to be we can find the square root and we get, and it is in fact 112, and we get t as 8. I have skipped some of the complications here, but we get t equals 8. Now, t was originally y cubed, so we get y cubed equals 8. This means that y is nothing but 2. So we've solved for y, but we do not know yet what x is, but it's quite simple from here. Z is 12 by y, so it's 12 by 2 and is 6. And x, we defined this earlier, that z equals x plus y. So x is z minus y. So the value of x is equal to z minus y, which is equal to 6 minus 2 equals 4. So in the end we get that the value of x is 4, and this is how Tartaglia solved the depressed cubic equation. I hope you learned something new in this video, and I hope you enjoyed, and I'll see you in the next one.